chemical equations, and the law of conservation of Lego. All right, let's see how this works. Let's take an example chemical equation and let's model that with Legos. Now, what do I mean by that? Well, let's take, for example, these little studs here. These little Lego studs would be hydrogen. So each little red stud represents an atom of hydrogen. And each blue cone stud here is going to represent oxygen. Now, the idea of the law of conservation of Lego means that however many Legos that I start with in my chemical reaction, I need to conserve and I need to have all of those Legos at the end of the reaction. So remember, the law of conservation of mass states that we do not create or destroy matter. We just kind of mix it around and move it around and becomes other things, right? So that's what chemistry is all about. So let's see how this works. If I want to model diatomic hydrogen, then that's two hydrogen atoms that are together. And I've got two molecules of diatomic hydrogen, and so there they are. And here is going to be, I'm going to represent with these blue cones, one diatomic molecule of oxygen. Now, if these two react, and by the way, this is a very famous reaction. The Martian actually synthesized water by combining hydrogen gas and oxygen gas. So what he did was he just rearranged the atoms so that he could produce water. So with these same four atoms of hydrogen, he combined them with two atoms of oxygen in such a way that he had two molecules of water. Look, see, I didn't take any Legos away. I didn't add any Legos. I just rearranged them, and these combinations of Legos are a model for water. Pretty cool, huh? Let's try that again with a little bit different reaction. Here is the decomposition of peroxide. You've probably got some peroxide sitting around at home in the first aid cabinet or in the medicine cabinet in your bathroom, and it's in a brown bottle. And it's in a brown bottle because if it gets too much light, if sun shines on the peroxide, it actually breaks down into plain old water, and oxygen gas is released from it. So here I've got a couple of models of of um, of peroxide. Notice the coefficient 2, meaning that I have 2 units or 2 molecules of peroxide, and each molecule of peroxide has 2 hydrogens represented by the red studs and 2 oxygens represented by the blue cone studs. Now, after time, if I was to expose these molecules to light, they would actually break down and form a couple of molecules of water and some diatomic oxygen gas. Okay, so here's my 2 molecules of water and my 1 molecule of diatomic oxygen. See, isn't that cool? So no Lego pieces were added, no Lego pieces were taken away. I've conserved the number of Lego pieces, and I've just rearranged them to form different molecules. Okay. So let's continue with something a little bit different. Let's look. Hey, we got some ammonia here, which is nitrogen and hydrogen. So the nitrogen atom is represented by the 1:3 brick, and of course, still the hydrogen is the single red studs. Ammonia can decompose to nitrogen gas and hydrogen gas. So again, we just rearrange these atoms, these Legos, to form diatomic nitrogen and 3. You're going to make me work hard here. 3 diatomic hydrogen gas molecules. Okay, so here we go. We have conserved all our Legos, and that's what we get. Okay, and one last time. Whoa, CH4 plus 2O2 produces CO2 and 2H2O. This looks like a combustion reaction. So here I've used a black stud to represent carbon, and then you see the 4 hydrogens surrounding it. And then here is a 1 diatomic oxygen, and here's another diatomic oxygen. Okay? Hey, why don't you pause the video and see if you can rearrange these yourself and come up with carbon dioxide and water. Oh, I'm sorry, you don't have these Legos? Okay, so let's do it. Let's take the CO2, so the carbon is the black in the middle, and we need to attach a couple of oxygens on it, all right? So here's a CO2 molecule, and then we need a couple of waters, right? So we've seen how we make waters with oxygen and 2 hydrogen. There's one of them, okay? And then there's the other, right? Hey, of course, this would have been a lot more fun if you would have been doing it, but hey, this is what e-learning is all about. Teacher gets to have all the fun.